I made a list here and I want to get to salicylates because you talk about that a lot and I didn't even know what it was until I Googled it. So
Right.
I wrote down phytic acid, gluten, tannins, oxalate, lectins, saponins, if I'm saying that correctly, trypsin inhibitors, isoflavins or flavonoids, solanine, and I don't even know how to say the last one, chiconine. And these are just 10 of the, and there are others, anti-nutrients um, that are in different either seeds or nuts or plants or nightshades. So I didn't even mention salicylates, but you bring that up a lot. Can you define, like I know that salicylic acid is an aspirin and it helps, I think it's an anti-inflammatory or something. It helps people with the headache or it thins the blood. But these occur naturally in a lot of fruits and fruit juices and some vegetables. So do salicylates and oxalates, do they cross paths? Is it something separate we need to look out for and worry about in another vein?
Well, let me bring a little bit of a sort of context here as well.
Okay.
Oxalate can be doing multiple things in the body. So it does have this chelation, so it can deplete our minerals. It's also a mitochondrial toxin. We're finding more and more information about it impacting the mitochondria. There's indication that it is, I'm going to say, triggering the immune system in a variety of ways. It may be irritating the mast cells. It may be producing sort of low level inflammation in the body. Like, so a variety of things where the immune system has to come up on alert, right? Because any inflammation in the body is the immune system's business.
Right.
That's its primary target when it's paying attention. And then the other thing that happens with oxalate is that you have certain cell transporters in your body that will pick up a nutrient outside of the cell, pull it in, and then that same cell transporter will take something that's a metabolic byproduct or toxin in the cell and push it out. So if we look at sulfate transporters and we look at bicarbonate transporters and chloride transporters, all three of those generally have the capacity to move oxalate as well. So when those transporters work properly, they go outside the cell, pick up the nutrient, chloride, bicarbonate, sulfate, pull it into the cell. So I'm going to focus on the liver because that's where this salicylate thing comes in.
Okay.
So if I'm a cell transporter in the liver and I want sulfate, sulfur being so key to so many detox processes, and the liver being one of the biggest consumers of sulfate in the body. So this cell transporter is going out to get sulfate, pulls it in. One of the things that the liver can either produce, or we'll talk more about it, but have in a cell, is oxalate. So ideally then the cell transporter pulls in sulfate, pushes out oxalate. That's how it should work. If you have a lot of oxalate in the body, that cell transporter, this ending, if you will, that goes out to grab the nutrient, well, it can pick up either oxalate or sulfate. So if you've got lots of oxalate around the cell in the body, in almost a case of mistaken identity, that cell transporter that really the cell wants sulfate can pull oxalate into the body, into the cell. Once it's in the cell is not necessarily going to automatically expend energy to push that oxalate back out, because what it needed was sulfate. So it will expend energy, I'm going to argue, first to send the cell transporter back out to try and get the sulfate that it needed. Okay. So what that means is that we have this cell transporter, which may be pulling oxalate into the cell and then going, oh, no, not that. Because oxalate, the cell can't do anything with it. Metabolic end product, toxic to the mitochondria. It wants to get rid of it ultimately. And so it wants the currency that it really needed to run the process. It needs that sulfate. And if we use currency as an analogy, if I go out to a store and I want to buy something and I have monopoly money, nobody's going to sell me anything for that. So oxalate is the monopoly money for the liver.
Ah,
So the liver is using sulfate to detox. And interestingly enough, salicylate can put pressure on some of these sulfur detox pathways. And so the less we can run these sulfur detox pathways because we're accidentally ending up with oxalate in there, it's not what we need, the harder it can be for us to get rid of salicylate. And that's where salicylate starts to be more and more of a problem. Because you're correct. Most people who find out that they have a salicylate problem used to find that out because they had a reaction to aspirin, which is salicylic acid. But now people can start to realize that they're having problems, particularly after eating fruit, which might even look a bit like histamine problems, because the immune system can get involved here too. So we it's really tough. There's this one Wizards of Ox video where we try to talk about this 3-ring circus of oxalate, histamine, and salicylate, because you can have symptoms that are just salicylate, just oxalate, just histamine, but you can have all sorts of things where you've got overlaps between two of these, and then you've got the center core where you've got all three of them probably going on.
Yeah.
And so it's not, in this case, we're looking at, it's not just what oxalate's doing, it's what's happening downstream of oxalate's impact in the body. And that's where you can have problems with things like histamine in your food. Histamine's not a toxin. Our bodies need it for all kinds of really good and healthy functions. But if your immune system's over revved because it's kind of chasing its own tail, because oxalate's got this low grade inflammation going on in different places that you might not even be consciously aware of, and your immune system's getting more and more vigilant because it's got a problem all the time. It's like talking to the nervous system, got a problem, got a problem, got a problem. Then histamine in your food can start to become an issue because it's adding to potentially a body burden of histamine that's not being broken down quickly enough because the body's kind of overreactive. And so we can have even things that are good and normally benign start to cause us some problems because it's downstream of what other toxins are doing. And salicylate becomes an issue because we can't clear it fast enough. So the detox process that we need to use with salicylate so that we take it out of circulation once it's done whatever we might benefit from, like reduction of inflammation. But if it's building up, the research says that this salicylate itself can become a mast cell irritant, and it can set off the histamine problem. And so you've got this 3-ring circus of things.
Oh gosh. So things that are kind of anti-inflammatory can become inflammatory.
It's one of life's great ironies here.
It's
and
crazy.
Things like histamine, where we use histamine to digest our food. We use histamine to manage our sleep cycle. So we actually use histamine in the brain for wakefulness, which was just made so much sense to me when I started to read this. So histamine actually will wake you up. But as it drops, that's the signal to the brain to go to sleep. So if your histamine levels are doing this, then you eat a meal and suddenly you want to sleep. What if it's not blood sugar? What if that's histamine?
And I wonder, a lot of people get drowsy after certain meals that's not related to the sugar and insulin. And
that would be one of those things where I'd want to explore trying something like reducing the histamine level in your diet, but also reducing the oxalate level, because if oxalate irritates the immune system and then the immune system's producing more histamine, you've got multiple dominoes to deal with there.
You can go crazy trying to figure the domino blocks.
And you really can. Like lots of times I'll say to people, we don't know who the biggest, baddest bad guy is here. We know there could be multiple ones in play.
Right.
So then I would say, take the pressure off your system, take down oxalate. It's a known toxin. take down salicylate kind of on principle, especially if you get really tired after having fruit.
Okay.